Hi, this is a test. This is only a test. I gotta test this stupid thing out and see if it gives me any sound. Let's do quadratic formula. Let's do the quadratic formula lesson. Hopefully you can see this. Going super low tech. Got some duct tape and a notebook and we're all set. The quadratic formula is a very nice simplified version of completing the square. If you don't remember completing the square, it's used when you have a quadratic and that you want to solve, and either it's factorable or it's not. Let's do one that's factorable. X squared minus 2x minus 8 equals 0. It's in standard form, as you can see. And you are going to complete the square, so you add 8 to both sides. And the whole purpose is to get a perfect square quadratic on the left and numbers on the right. And then you can solve it. In order to make this a perfect square quadratic, we want it to look like this. And we're going to have something on the other side. There'll be a little extra here. Now, in order for this to happen, we look at our middle term and we can see that we have a minus 2x. So this must have been, and since this is an x squared with no leading coefficient, there's a 1 here, even though you don't see it, we have an x minus half of this. Because if this is a minus 1 and I square it, I'm going to have a minus 2x here. So this is x minus 1 squared. Since I want this to be over here, I need to add a 1 to this side. If I add 1 to the left, I have to add 1 to the right. So I actually have a plus 1 there. Now this is completing the square. So now I have x minus 1 quantity squared is equal to 9. In order to solve this, there's a lot of ways of thinking about it. You can undo the mathematics, which is taking the square root of both sides. But a little more intuitive way of doing it is to eliminate this or cover this up. Now think about what number squared equals 9. We're kind of doing the fill-in-the-blank type algebra. And you can see most people realize that 3 times itself is equal to 9. So 3 squared is 9. So whatever's under my finger has to be equal to 3. But you can also say that negative 3 squared is equal to 9, and so whatever's under my finger could also be equal to negative 3. So there's two ways of thinking about it. I like to think of it as the fill in the blank. So x minus 1, whatever's under my finger, is equal to 3 or negative 3, whatever's there. So there's a 3 or a negative 3 under my finger, so this is x minus 1 is 3 or negative 3. We can write it like this. X minus 1 equals 3, or x minus 1 equals negative 3. And we solve these two parts separately. A very common mistake is to want to take the square root of both sides, and don't forget it could be plus or minus because you're solving. And what they'll do is they'll do this. X minus 1 is equal to plus or minus 3, which is okay, and then add 1 to both sides. You get into problems when you have a leading coefficient for this, but anyway, here it is. This is the more efficient algebraic method. I prefer the fill-in-the-blank type method. I'm going to add 1 to both sides, and I get x is equal to 4, and over here I'm going to add 1 to both sides, and I get x is equal to negative 2. These are my two solutions to that original quadratic equation. Now that's completing the square. The quadratic formula basically does the same thing all in one step. So the quadratic formula says that if we have a quadratic in standard form, ax squared plus bx plus c is equal to 0, which this clearly is. There is a 1 in front of the x squared, which gives us our a. Our b isn't being added, so we can think of this as plus a negative 2, and b is negative 2. Very important to get that straight. And c is negative 8, because this is always plus c, and subtracting 8 is the same as adding a negative 8. So c is negative 8. A equals 1, b equals negative 2, and c equals negative 8. And what the quadratic formula says, or what the quadratic formula theorem says, is that if you have a standard form quadratic, your x is always equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the pop goes the weasel type quadratic formula. Anyway, so we have a b, we have a b, we have an a, we have a c, we have an a. A very, very common mistake is for students to look here and see b equals negative 2, and see the negative b, and see the negative 2, and want to do the following. They want to write negative 2, which of course is incorrect from the very beginning, and you'll never get it right. So, my suggestion to you is at first, substitute all of your variables for parentheses. I also make another suggestion here in a second. But instead of variables, you'll notice I'm writing parentheses. Now, notice that I substituted b and I put a negative 2 instead of b, but that negative is still there. Very important to include it, because that double negative gives us a positive 2 to start our quadratic formula with. This negative 2 is important because if you square a negative 2 in parentheses, you get a positive 4. But if you square a negative 2 without parentheses, you get negative 4. It's kind of a problem. So be careful with that. A is 1, and c is negative 8. C, here's the a, and here's another a down here. So our x is equal to this expression. This is called an arithmetic expression that we're going to simplify. We have to use order of operations, and remember a double negative is a positive. Another way of thinking about this is that parentheses can be thought of as multiplication. This is a negative times a negative, if you like. This is a positive 2. The plus or minus gives us our two different solutions because we're finding an unknown square root. This is the square root of negative 2 squared is our positive 4. And here's the change I make. You can think of this subtraction and you can do this separately, and then at the very end think of subtracting whatever you get here. But it's so much more efficient and simple to think of this as plus a negative 4ac from the very beginning, and then you're only dealing with multiplication. A lot of times this negative ends up being canceled with this negative, and we end up with a positive 32. This is negative 4 times 1 times negative 8, which is positive 32, all over 2 times 1, which is 2. I can simplify this even though it's out of order because it's separated by the division line. This is inside of a radical. A lot of times you may not see this radical, especially if you're working with a calculator, so it's important that there are parentheses and thought of as parentheses. This is 2 plus or minus the square root of 36 over 2. Now this is where quite a few people break down and they have a problem. This is pretty simple now. It's just 2 plus or minus 6 over 2 because the square root of 36 is 6. And I like to actually separate this into two parts. I have the 2 plus 6 over 2. That's a plus, by the way. And I have a 2 minus 6 over 2. The 2 plus 6 gives me 8 over 2, which is 4. And the 2 minus 6 over 2. 2 minus 6 is the same as 2 plus negative 6, which is negative 4 over 2, which is negative 2. And we have our two solutions, x equals 4 or negative 2. These are both solutions to the quadratic equation that we started with. notice that we got the same answers when we did completing the square. It may seem longer to do the quadratic formula, but the difference is that the quadratic formula always works. I'm running close to my 10-minute limit, so I'm actually over. Hopefully this works out. We'll find out.